Welcome everyone. For today's prep, we're going to look at another of our major indefinite integral properties. So in class, we looked at the constant multiple rule. So as just a reminder, what this rule says is if we're trying to find the antiderivative where we have a constant k multiplying some variable stuff, what we can do is focus in on that variable stuff, get the antiderivative for that, and then just multiply the result by that constant. So we also have sum and difference rules. So what these say is if we have one variable term, call it f of x, and then another variable term that we're either adding or subtracting in, well, we can first focus in on the first variable part, get the antiderivative of that, and then we can focus in on the second variable part, get the antiderivative for that, and whatever addition or subtraction was in between those two in the kind of the original expression, well, in our antiderivative, we're going to have either the plus or the minus in between the two antiderivatives. So let's give this one a try with a couple examples. So we did some constant multiple rules. Here we go. All right, so in the first example here, what do we have? We're trying to find the antiderivative of the function 2x to the power 7 plus 6x plus 5. So when we look at this, kind of see three separate terms. So we've got the 2x to the power 7, we've got the 6x, and then we've got the 5 at the end. So we have three separate terms here, and in this case we're adding them all together. All right, so we want to find the antiderivative of this. So the idea here with this sum rule is we're going to focus in on first getting the antiderivative of that 2x to the power 7. Then we'll get the antiderivative of the 6x. And then we'll get the antiderivative of the 5. And essentially the integration or the antiderivative process here keeps the structure the same. So there's going to be plus signs in between each of those antiderivatives. So the plus signs in the original function, they're going to stay plus signs in our antiderivative here. So let's get the antiderivative of that first term. Kind of just focus in on that. So the 2 is a constant multiple, so we can just kind of leave it in front. And then we do power rule on that x to the power 7. So our variable is x. We add 1 to the exponent, so we get 8. And then we take the 8, we flip it and put it in front. So we have a 1 over 8 in front. All right, so that's our antiderivative of the first term. So now we move on. We go to the second term, which is 6x. So the 6 is a constant multiple. And we work on getting the antiderivative of the x. And again, this is just power rule, so there's kind of a hidden exponent of 1 there. So if we do our power rule there, we add 1 to the exponent, so it's going to bump us up to 2. And then we take that new exponent, we flip it. And then for the 5, integrating a constant that's all by itself, the constant stays put, but then we multiply by our variable. So in this case, our variable is x. And then with any of these indefinite integrals, we're going to throw a plus c on at the end. And usually it's a good idea, and probably once you get the hang of this, you'll be able to just kind of simplify these right as you go. So 2 divided by 8 is 1 over 4. And then 6 divided by 2 is 3. So we get a nice clean antiderivative there. All right, let's try another one of these. So let's look at part B. So when we look at this one, again, we see kind of two separate terms. And we have subtraction in between those two terms. So we can focus in on getting the antiderivative of just that first term, and then getting the antiderivative of just that second term, and essentially the structure is going to stay the same. Now, before we go on with this one, I just want to rewrite this fraction here, just to make the power rule a little bit easier. So we're going to rewrite this. The 5x to the 4, that one's fine. That one's no problem. But I'm going to rewrite this fraction as negative 4 x raised to the negative 3. So I'm just rewriting this fraction using a negative exponent. And that'll make power rule a little bit easier. So what we got? We have one term, we have a second term, and then we have a minus sign in the middle. So what our sum and difference law says is essentially this antiderivative process keeps the structure the same. So when we do this, we're going to find the antiderivative of the 5x to the 4. We'll find our antiderivative of that 4x to the minus 3. And then the minus sign that is in the middle, that's going to stay the same. All right, so let's get our antiderivative of 5 times x to the 4. So the 5 is a constant multiple, so we'll just kind of put it out in front. And then we can focus in on getting the antiderivative of that x to the 4. So our variable is x. We add 1 to the exponent, so we go from 4 up to 5. And then we take this new exponent and we flip it. And we put the reciprocal. Make that a little easier to read. We put the reciprocal in front of the x. And again, once you get the hang of these, you'll probably be able to simplify this, as you go. All right, so then for the second term, we have the 4 in front. So the 4 is just going to stay there. And then let's get the antiderivative of that x to the minus 3. So our power function has base x, so we keep the x the same. We add 1 to the exponent, so it's going to take us from negative 3 up to negative 2. And then we take that new exponent and we flip it. We put the reciprocal in front, so 1 over negative 2. And then as usual with these indefinite integrals, the customary plus c at the end. All right, and we can simplify this down. So 5 divided by 5 is just 1. So we end up with x raised to the power 5 for that first term. And then negative 4 divided by negative 2 is positive 2. So we end up with positive plus 2 x raised to the negative 2. And then our plus c. All right, so there's our antiderivative. So now these properties, these constant multiple rule properties and the sum difference rule properties, what this allows us to do is it allows us to take different functions and really kind of algebraically combine them to form new functions. So we're going to need some kind of building blocks to know what the antiderivative of some building block functions are. So far we've only been really dealing with power functions. Well, we have a whole bunch of elementary forms that we can memorize. So we've seen the first two already. So if we're integrating just a constant, well, the constant stays the same and then we multiply by our variable x. And then this is the power rule that we've been using. So the first one we've looked at, this is the constant function. And this one, the second one here, is power rule. So this is probably the one we've been practicing the most. Now, power rule, when we first introduced it, power rule, we said only worked if the exponent n did not equal negative 1. So that was kind of the one little caveat there for power rule. Works most of the time. Works for most power functions, except when the exponent is negative 1. And when n does equal negative 1, well, it's something special. So for a power function, when it is x raised to the negative 1, or we could rewrite that as 1 over x, this is something different. The antiderivative of 1 over x is natural log of absolute value x. Okay, so this kind of completes the picture for our power rule. All right, and then we have a list of a whole bunch of elementary forms that really you just want to have memorized. So if we're integrating e to the x, Well, the antiderivative of e to the x is just e to the x. And then for exponential functions that are a different base, basically they're the same except we divide by natural log b. Integral of sine x is negative cosine. Integral of cosine is sine. So we've got our trig functions here. We've got our exponential functions. And then at the bottom here, we have a couple for our inverse trig functions. So the integral of 1 over 1 plus x squared gives us inverse tan, and the integral of 1 over square root 1 minus x squared gives us inverse sine. Now, it might look like we have all this new stuff to memorize here. But it turns out that we've seen all this before, just in a different context. So let's remember our derivative rules. So let's remember, well, let's look at what's a couple derivative rules we could do. Let's do 3 of them. Well, maybe not 3. Let's do 2. So let's do the derivative of cosine. So what was the derivative of cosine? Well, it was negative sine of x. And what was the derivative of, let's do tangent. Derivative of tangent. Let's do another trig function. What was the derivative of tangent? It's secant squared. So when we look at these derivative rules here, so all these derivative rules that we had memorized, what we're seeing on the right side of the equation here, this is the derivative. Okay. So if we're taking tangent x and we want to differentiate, derivative of tangent is secant squared. But we can read this backwards. So instead of reading this kind of in this direction, we can read this in this direction. So if we have secant squared, the term inside the brackets here, that's our antiderivative. So again, you can kind of read this in 2 directions. So if we're reading it this way, then yeah, secant squared is the derivative of tan. But if we read it the opposite way, well, tangent is the antiderivative of secant squared. And that's precisely what we're seeing right up here. The antiderivative of secant squared is tangent x. So, and that goes for all these other ones here to memorize as well. These are all, we've kind of done these with our derivative rules. Now we're just working backwards. So if we look at, say, for cosine, again, cosine, if we were doing the derivative of cosine is negative sine. So if we were kind of going in this forward direction, that would be the derivative. But if we were trying to integrate negative sine, if we were trying to go back, well, then the antiderivative of negative sine would be cosine. And that's what we're seeing in here. So that's our antiderivative. And that's precisely what we see on our table. The only thing we just adjusted for the negative, the constant multiple of the constant multiple there. So we had a negative in front of sine. So if we're starting with sine, well, then we're going to get negative cosine. So we're just kind of accounting for that negative constant multiple. So that's what we're seeing on this table. So yeah, it's a bunch of new stuff to memorize, but we've seen it in some format before. So what I would recommend, write up some 3x5 cards, put sine x on one side, negative cosine x on the other side, and then you can kind of quiz yourself on what's the function and what's the antiderivative. Okay, So we're going to practice some of these in class using that table of antiderivatives. So we're going to look at some of these next time. So we'll see you then. Bye-bye.